In the chapter electromagnetic induction, the next point we have to discuss here is about the AC generator. What is AC generator? On which principle it works? And also we have to discuss about its construction, working and theory. All these points we have to discuss regarding the AC generator. What is AC generator? Right? The AC generator is a device or the machine which converts mechanical energy into electrical energy in an alternating manner. Right? It is an electrical machine used for what? To convert mechanical energy into electrical energy is known as AC generator or AC alternator, and it was invented by Nikola Tesla. Depending upon the type of mechanical energy, based on the type of mechanical energy used, there are three different types of generator, such as what? Hydroelectric power generator, thermal power generator, and nuclear power generator. So based on the type of mechanical energy used, this classification is done. Now let us see about its principle, on which principle the AC generator works. The AC generator works on the principle of electromagnetic induction. That is means what? When a coil is rotated in a uniform magnetic field, an EMF is induced in it. So you know that what is meant by electromagnetic induction. Whenever there is a change in the magnetic flux linked with the coil, an EMF is induced in it. So that is known as what? The electromagnetic induction. So in AC generator, what happens? The coil is rotated in a uniform magnetic field and EMF is induced in it. So this is the principle of what? The working of AC generator. The modern day generators produces electric power about 500 megawatt. So by this much amount of energy, one can light up 5 million 100-watt bulbs. That means what? These modern day generators produces electric power about 500 megawatt, right? 500 megawatt means what? One can light up 5 million 100-watt bulbs, and the frequency of rotation is 50 Hz in India, and in certain countries such as USA it is 60 Hz. Right? Now the next point let us discuss here is about the construction of AC generator. The main parts of AC generator, the essential parts of AC generator are as shown in the figure here. There are four important parts of AC generator are armature ABCD, field magnets N and S, slip rings R1 and R2, brushes B1 and B2. These are the four important parts of the AC generator. Now let us discuss the parts of AC generator one by one. The first one, armature. The armature ABCD. It is a rectangular coil consisting of a large number of turns of insulated copper wire. So what is armature? It is a rectangular coil. It is a rectangular coil consisting of a large number of turns of insulated copper wire. The wire is wound on a insulated laminated soft iron core, and it can be rotated about the central axis. So this is the important part of what? The AC generator, right? The armature, it is a rectangular coil consisting of large number of turns of insulated copper wire, and it can be rotated about the central axis. Next one, about the field magnets, right? The field magnets N and S. A strong permanent magnet or an electromagnet whose poles N and S are in cylindrical shape used as a field magnets. So here we are using field magnet as what? Electromagnet whose poles N and S are in cylindrical shape. The armature coil rotates between the pole pieces of a field magnet, right? The armature coil rotates between the pole pieces of the field magnet. The uniform magnetic field is provided by the field magnet and which is perpendicular to the axis of rotation of the coil. That means what? The uniform magnetic field provided by the field magnet, that is perpendicular to the axis of rotation of the coil. So this is the next important part of what? The AC generator, that is what? The field magnet. The first important point is what? The first part is this armature coil ABCD, and the second one is what? The poles, that is field magnets N and S. And the third one is about the slip rings. So what is a slip rings? So this R1 and R2, right? This R1 and R2 are known as what? The slip rings. They are the two hollow metallic rings which are connected to the ends of the armature coil, and these rings rotates with the rotation of the coil. So what is a slip ring? These are the two hollow metallic rings which are connected to the ends of the armature coil, and these rings rotates with the rotation of the coil. Now the third one is about slip ring, and the next one is about the brushes B1 and B2, right? The brushes B1 and B2, they are the two flexible metal plates or the carbon rods. They are fixed and lightly pressed against the two slip rings. These brushes are used to pass on the current from the coil to the external circuit. So brushes are also very important parts in the AC generator. The two carbon brushes B1 and B2, these are pressed against against what? The slip rings. The brushes are used to pass the current from the coil to the external circuit. So these are the four important parts of the what? The AC generator. The first one, armature, that is ABCD, which is a rectangular coil, and the field magnets N and S, which are in the cylindrical shape, and they produces the uniform magnetic field which is perpendicular to the axis of rotation. And the third one about the slip rings, and fourth one is about the brushes. So this is the construction about the AC generator. Now let us discuss about the working of AC generator. I hope the construction of AC generator is understood, and it is very simple. The principle is what? When the coil is rotated in a uniform magnetic field, an EMF is induced in it. So that is the principle of what? AC generator, that is electromagnetic induction. So we are producing the uniform magnetic field by using the electromagnets which are in the cylindrical shape. And second one, the coil is used here, that is ABCD rectangular coil, which is armature. And third one, the slip rings, they are the hollow metallic rings which are connected to the ends of the armature coil. These rings rotates with the rotation of the coil. And the fourth one, the brushes are used to pass the current from the coil to the external circuit. So this is the important parts of the and the construction of the AC generator. Now let us discuss here the working of AC generator, how it works. That means what? When the coil is rotated in a uniform magnetic field, an EMF is induced in it. Now let us see about its working. When the armature rotates in a uniform magnetic field, when the coil rotates in a uniform magnetic field, the magnetic flux linked with the coil changes. As a result, an EMF is induced in the coil. This EMF induces the current in the coil, and the current is passed on the external circuit by means of slip rings and brushes. So what happens in the working of the AC generator? When the armature coil ABCD rotates in the magnetic field provided by the strong field magnets, It cuts the magnetic lines of forces. That means what? The magnetic flux linked with the coil changes. The magnetic flux linked with the coil changes due to the rotation of the coil, that is armature, and hence EMF is induced in the coil. So this is the main important principle, that is what the electromagnetic induction, right? The magnetic flux linked with the coil changes due to the rotation of the armature, and hence EMF is induced in the coil. The direction of the induced EMF or the direction of the induced current is determined by the Fleming's right hand rule. So how to find the direction of the induced EMF or the induced current? By using the Fleming's right hand rule. By using the Fleming's right hand rule, we have to find the direction of the induced EMF or the induced current in the coil. So the current flows out through the brush B1 in one direction, that is in the half revolution. So what happens in the first half revolution of the coil? The current flows out through the brush B1, and in the next half of the rotation, current comes out through the brush B2 in the next half revolution in the reverse direction. So that means what? This process is repeated continuously, and therefore the EMF is produced is of what? The alternating nature, right? That we call it as what? The alternating current, right? The current flows out through the brush B1 in one direction, that is due to first half of the revolution, and in the next half of the revolution, what happens? Current comes out through the brush B2 and in the reverse direction, right? So every half rotation, the direction of the current changes here. This process is repeated, and therefore the EMF produced in the coil, it is what? The alternating nature. Therefore the induced EMF or the induced current, it is called as what? The alternating EMF or the alternating current. So next one, from this figure we can understood here the variation of the induced EMF with different position of the coil with respect to the magnetic field. The expression for the induced EMF, that is equal to E is equal to E naught sine theta, where theta is equal to omega t. Now we are going to discuss this expression in theoretical part, that is E is equal to E naught sine theta. This is the expression for the induced EMF. Now from this expression we can discuss here the variation of the induced EMF with the different position of the coil with respect to the magnetic field. So now we can say here from the first case, that is about when theta is equal to 0 degree. When theta is equal to 0 degree, the plane of the coil is perpendicular to the magnetic field. That means the plane of the coil is perpendicular to the magnetic field, and in this case theta is equal to 0 degree. That means sin theta, when theta is equal to 0 degree, sin 0 is 0. Therefore induced EMF E is equal to 0. Therefore the induced EMF E is equal to 0 in the first case, right? Therefore E is equal to 0 here. Induced EMF is equal to 0 at theta is equal to 0 degree. Next, in the second case, when theta is equal to 90 degree, right? When theta is equal to 90 degree, that is the plane of the coil is along the direction of the magnetic field, right? The plane of the coil is along the direction of the magnetic field. Theta is equal to 90 degree. Sin 90 is 1. Therefore E is equal to E naught. So induced EMF, what you will get here? E is equal to E naught. This is the maximum value of the induced EMF you will get at theta is equal to 90 degree, right? And third case, in the third case, what happens? Theta is equal to 180 degree. Theta is equal to 180 degree means that is the plane of the coil is perpendicular to the magnetic field. Perpendicular to the magnetic field, that means theta is equal to 180 degree. E is equal to E naught sine 180 degree. So sine 180 degree is equal to 0. Therefore the induced EMF is equal to 0 at theta is equal to 180 degree, right? At 180 degree the EMF is equal to 0. So in the next case, what happens when theta is equal to 270 degree? Theta is equal to 270 degree. Fourth case, when theta is equal to 270 degree, that is the plane of the coil is along the direction of the magnetic field. That means theta is equal to 270 degree. Therefore, sine 270 is minus 1. Sine 270 is minus 1. Therefore, E is equal to minus E naught. Right? E is equal to minus E naught you will get here. Right? E is equal to minus you will get here, right? And in this case you will get plus, right? So at theta is equal to 90 degree plus E naught, that is the maximum value of the induced EMF, that is positive. It is in one direction, and in other direction theta is equal to at theta is equal to 270 degree you will get the maximum value of the induced EMF. It is on the other direction. So in this way we have to explain about the variation of the induced EMF with respect to the magnetic field and the value of theta. And in the next case, what happens when theta is equal to 360 degree? Again, at theta is equal to 360 degree, one rotation completes and the plane of the coil is perpendicular to the direction of the magnetic field, and theta is equal to 360 degree. Sine 360 is 0, right? Sine 360 is 0. That means again the induced E is equal to E naught sine theta. Theta is equal to 360 degree. This sine term becomes 0. Therefore, induced EMF is equal to 0. So in this way, there is a variation of alternating current takes place, that is the induced EMF or the induced current. When the coil is rotated from its position at right angles to the magnetic field, through 180 degree, the induced EMF and the induced current increases from 0 to maximum and then decreases from maximum to 0 in the same direction. And when the coil is further rotated through the next 180 degree, the induced EMF and induced current increases from 0 to maximum and decreases from maximum to 0 in the opposite direction. So this is about the construction and working of AC generator, and the expression for the induced current, that is AC current, that is I is equal to I naught sine theta. So all this about what the construction and working of AC generator, and we have to discuss about its theory, right? We will explain the theory part of the AC generator in the next video class. So this is about what the construction and working. One more important point, that is about the direction of the induced current or the induced EMF is determined by the Fleming's right hand rule. This rule is used to determine the direction of the induced electric current. So according to this rule, if the first three fingers of the right hand are stretched at perpendicular to each other, then the thumb points in the direction of the motion of the conductor and the index finger points in the direction of the magnetic field, and the direction of the induced current is determined by the middle finger. The middle finger indicates the direction of the induced current. So the Fleming's right hand rule is used for what? To determine the direction of the induced current within an electric generator. Right now, let us see here how this rule is used to find the direction of the induced current in AC generator. So in this figure, the rotation of the coil is in clockwise direction, right? This coil is rotating in clockwise direction. The coil is rotating in clockwise direction here, right? So in the first case, what happens? This one, when the coil is moving in upward direction, right? The motion of the conductor or the coil is in the upward direction. The field is right angles to the axis of rotation. This is the direction of the magnetic field. This is the direction of the motion of the conductor. So what is the direction of the induced current? So the direction of the induced current in this case is this one. So this is the direction of the induced current, right, according to Fleming's right hand rule. again when the coil moves in downward direction, right? The coil is moving in the downward direction. After half rotation it starts to rotate in downward direction. So this is downward motion, and this is the direction of the magnetic field. Now again, according to the Fleming's right hand rule, the direction of the current is this one, right? So in this way you have to find the direction of the induced current within an AC generator by using the Fleming's right hand rule. So you have to stretch your uh, first three fingers of the right hand. They should be perpendicular to each other. Thumb points in the direction of the motion of the conductor, and index finger is in the direction of the magnetic field. Then the direction of the induced current is the central finger gives the direction of the induced current. So you have to practice it by taking the different examples, and you will understood it very easily. Very simple law, that is the Fleming's right hand rule. It is used to find what? The direction of the induced current or the induced EMF, right? So this is all about the what, the construction working and how to find the direction of the induced current in case of what, the AC generator, right? So in the next video class we will discuss about the expression for the induced EMF in case of AC generator, the expression for the the expression for the induced EMF, that is theory part. We will discuss it in the next video class. Okay, thank you students.